Welcome back. So it's been just over a month since the last AS video, since I was uploading all of the October-November 2024 past papers. However, since I finished those, well, now hopefully I'll start uploading these again at, a fairly regular schedule. So if you look here then, well, alright, so we're just going to continue from where we left off, which was Unit 2 and IP addressing. Right, a quick video overview. Well, first we're going to look at IP version 4, right, the addresses and also format. We'll also look at some exam style questions where alright, so basically they'll give you an IP version 4 address, and they'll just ask you to say, well, is it valid, is it invalid, and also give a reason why. Right, then we'll just quickly look at the history of IP. Right, we'll then look at something called, well, the network ID and host ID are basically the two components of an IP address. Right, then we'll look, so this one, alright, so we can basically say, well, three ways of splitting the IP address into the network ID and host ID. Right, one of them was called IP classes, and I think this one hasn't been used since about 1993. So yeah, basically this is kind of the, archive, vintage method. Right, okay, then there's something called CIDR, right, classless interdomain routing. Right, and then finally, subnetting, and subnetting, really, so subnetting, basically that's what's used today. Right, and then, finally, we'll just look at the advantages and disadvantages of each, and yeah, for example, why subnetting has won out over the other two. Right, so if we look at IP addresses now, sometimes in the exam they might ask you, what does IP stand for? So that's going to be Internet Protocol. And of course, hopefully fairly obvious, right? Well, yeah, the I and the P, right, coming from the first letter. So, when it was first built, or I guess, first kind of created, developed, right, a public IP address would uniquely identify every device in the world. And the reason for that is, because, so basically when it was first made, there just weren't many people using it. Really just, alright, so I guess mainly just military and also some universities. So you didn't have, billions of people using the internet, right, like you do today. So effectively you can think of it kind of like a house address, but rather than, identifying a house, in this case it's going to uniquely identify, and to be honest, right here, probably a computer is not the best word. I guess really we can say a device, because, alright, so if we say device, that could be a computer, but it could also be a phone, it could be, it could be a tablet, right, it could be a car, if you've got some, car that's connected to the internet. Also, things like a fridge, various other kind of IoT, right, Internet of Things devices. Right, so if we look at the history of IP version 4, so it was planned in the late 1970s and introduced in 1982. At this point, as mentioned, the internet was just used for the military and universities. Right, they didn't believe it would ever grow to the size that it did, because I guess really, for them, it was just an internal system. It was never really designed to be, released to the public. Alright, so I guess some people might know this if they've done IG, but let's look at the format of IP version 4. And also, let's think, right, alright, so therefore, how many different IP version 4 addresses are there? So if we just think then, IP version 4 is going to be 32 bits, and they're written as 4 groups of numbers, from 0 to 55. 0 to 255. Now, that's obviously going to be in denary format. For the computer, so for the computer, right, the router's devices, IP, right, of course, right, alright, so all of it's just going to be in binary. But when we're thinking about, kind of making it human readable, human readable, then we're just going to write in denary. So, for example, 192.168.0.1. Now, a lot of people have probably seen this IP address because, this is going to be a private IP address. And if you're just on a home network, then probably, one of your devices is probably going to have this IP address. Either your computer or, maybe, a family member's computer, for example. Right, so since there's 32 bits, alright, so this gives us 2 to the power of 32 different addresses, or approximately, 4.3 billion addresses. And the reason I put that in red, if you think about how many people are in the world, right, hopefully people know, I think, now there's more than 8 billion people. But yet here we've only got 4.3 billion, unique IP addresses. So I think, people can probably, figure out that's going to be a problem. And that one we'll look at in a minute. Alright, so just the history then. 1969, I guess what you see is going to be alright. So, right, if we say, this is ARPANET. Now, ARPANET, basically just the precursor to the internet. Kind of the initial version. Right, so they've got alright, so basically they've got one kind of base in Utah, right, SRI, not really sure what that is. UCSB, so University of California, Santa Barbara, obviously, UCLA, right, University of California, Los Angeles. Right, by 1982, well, you can see it's obviously expanded, but I mean, even then, well, 13 years, I mean, basically it's still just really in America. I guess well, okay, yeah, you've also got London there. I mean, yeah, that one I'm not really sure what that is. But even if we look at this, well, still again, right, yeah, okay, all right. So if we look at this, well, this is still, just universities, military. Yeah, for example, Harvard. Well, yeah, the Pentagon. Right, so if we think, well, what's the problem then of only having, what, about 4.3 billion IP addresses? Now, as mentioned, well, right, okay, all right, so actually, I think now there's more than 8 billion people. Yeah, so let's say, well, there's more than 8 billion people, and most people now have internet access. And to be honest, most people are actually going to have multiple devices, right, that are connected to the internet. So, for example, a laptop, a desktop, tablet, right, phone, TV, yeah, I mean, car, again, if it's some, internet connected car, right, games console, and again, yeah, again, all right, so things like IoT devices, right, fridges, CCTV cameras, yeah, I mean, I don't know, even like, well, I think some people even have like a toaster, their sort of central heating or air conditioning system, yeah, like, yeah, I mean, all right, so all kinds of things. Right, so the problem with this then, IPv4 wouldn't be able to uniquely identify all these devices, so change had to be made. And right, some of those changes, well, one is going to be subnetting, so basically just kind of breaking down a big network into lots of smaller networks. And the reason for that, well, basically we can get a right, okay, all right, so let's say we can get kind of a greater utilization of the IP space, so we're not going to have as many wasted unused IP addresses. And if that doesn't make sense, which, well, to be honest, it probably won't do at the moment, but subnetting, well, we'll look at this later in the video. Right, if we look at, well, dynamic and private IP addresses, now this will actually be a future video. If we say dynamic IP addresses, right, just quickly, basically what that means is, well, rather than one person having an IP address and, just keeping that IP address, yeah, basically, forever, well, what's going to happen is what you would do, all right, so let's say when you turn on the device, well, then it's going to go to the DHCP server, right? Right, okay, all right. So dynamic host control protocol server, and really that's just going to be in your router. Now your router, that's also going to ask for a dynamic IP address, from your ISP. But basically, what's going to happen? Well, right, okay, all right. So when you turn on the device, well, it's going to ask for an IP address. But then when you turn off the IP address, well, after yeah, okay, all right. So after a certain amount of time's expired, well, then that IP address is going to be released, right? Just so that someone else, right, or a different device can use it. In contrast, static IP addresses would be fixed, and that means even if the device is off, well, that IP address is still, kind of technically in use, right? Yeah, unavailable to be used by other people. All right, then private IP addresses. So this means, well, rather than everyone having a global kind of public, right? Right, okay, all right. So yeah, okay, right. Rather than everyone having a globally unique public IP address, well, what you're going to do, all right, okay, all right. So let's say if you're on a LAN, well, the router is going to have the global, publicly, sort of unique IP address, but then the actual individual devices on that LAN, well, they're just going to have a private IP. So what this means is, well, basically you don't have as many people having a public IP, right? Therefore, it's not going to use up as many of the 4.3 billion available addresses. And if, let's say, a device on one network wants to communicate, with a device on another, well, since it's going through, kind of via the routers, well, since the routers have a public IP address, right, then, the communication is going to work, because what you'd have, okay, all right. So let's say, well, this router is just going to, send to the public IP address, right, of the device's, receiving router. Yeah, all right, and yeah, okay, all right. So again, don't worry if that doesn't make sense, because, well, I think next video we'll probably look at both of those two. Right, so if we look at IPv4, well, let's think then, why did they choose to use 32 bits to represent IP addresses when IPv4 was created? So if we see, well, as mentioned, it was never expected that more than 4 billion would be needed, because okay, again. So basically, it was just developed, for universities, for military, kind of a closed system, and to be honest, really, it was probably developed, just to be used in America. Yeah, I guess from then obviously expanded worldwide. Right, also internet speed was slow and data was expensive, actually having to transmit the data over the wires, right, it's going to be costly. Right, so both the source and destination IP address are sent with every packet, right, therefore you want to keep packet size as small as possible. Now, if we think, right, okay, all right, so if we think, well, IP version 6, now IP version 6 is the new one, Alright. So when I say new one, well, yeah, the new version of IP. And the main reason that was introduced was to kind of alleviate this, IP version 4 shortage. But the thing is, IP version 6, well, that uses 128 bits, right, for each address. So if in each packet you're having to send, the source and destination, well, of course, that's going to be 128 times 2, right? That's going to be 256 bits. Whereas, alright. So in contrast, IP version 4, right, since they're only 32 bits, well, then you're only having to send, 64 bits total. So yeah, I guess that was, also another reason. Although, to be honest, the second point probably isn't as relevant, since even if you just use an extra 8 bits, right, for example, 2 to the power of 40, well, 2 to the power of 40 is going to give you this. And, I mean, that's, honestly, I'm not even sure what that is. I think that's trillions. Maybe, okay. Alright, so I think that's trillions, or maybe bigger than trillions. Alright, so if we look at the format, and again, they often ask this in exams, right, so the format was going to consist or comprise of a network ID and device ID. Right, for example, a company could buy a network ID of, 200, 200, 200, right, that's going to be 24 bits. Right, that then gives them 8 bits remaining for the device ID, since we said, IP version 4 is going to be 32 bits. So the valid IPs, or I guess, the valid IP range for the devices in that network, right, would hence be, 200, 200, 200, right, because, alright, so if we look at this, this is going to be the network ID, right, then the device ID, that's going to be the remaining 8 bits. So the remaining 8 bits, that's going to be from 0, right, up until, 255. So hopefully you can see what that means is that we're on this network, okay, that means we can have 256, right, different devices. 256 unique devices. And then, alright, so that's just what that says there. Right, okay, so, alright, so this is if we're using, CIDR at classless interdomain routing, or, now it's going to be subnetting, right, that's the sort of more modern version. So the split could be any values that add up to 32. So here I just choose 24 bits for the network ID and 8 bits. Alright, so, alright, so let's say not for the client. I guess we can say, the host ID, the device ID. However, you could have it where, I don't know, let's say you have 28 bits for the network ID and, only 4 bits, right, for the host ID or device ID. That's just going to depend on, how many, alright. So that's going to depend on how many devices you actually need in the network. And, alright, so again, we'll look at that later. Right, so let's try this then, similar to exam questions. So let's see this one, is this valid or invalid? And I think what I'm going to do, alright, so let's just show all of them. And, right, what you can do, you can pause the video, right, try to think, and, when you've done that, alright, then, just resume the video. Okay, so if we look at the first one, if you remember, we said, alright, so the range of the groups, can be, 0 to 255. Now, if we look at this one, of course, 1, 2, 3, 4, right, 1,234, right, that's bigger than 255, right, hence invalid. If we look at the next one, so here, alright, so let's count the groups. Here's group 1, right, group 2, group 3, and group 4. Okay, so this seems valid, since, all of these are within, 0 to 255. Right, then if we look at the next one, so the next one here, 256, obviously that's too big. Right, then if we look at the final one, let's count the groups, right, so 1, 2, 3, 4, and 5. Right, so since it has 5 groups, that's invalid, because if you remember an IP address, right, so IP version 4, right, should only have 4 groups. Now if we look at IP version 6, IP version 6, that's going to have 8 groups, although, that will be probably the next video. Right, so if we just kind of recap quickly about routers, so usually device ID on the network is usually kind of reserved, or it's used for other purposes. I think they say sort of testing, maybe a sort of like diagnostics, right, things like that. Right, so routers will often, right, but not always have device ID 1, just being sort of first device on the network. And if we actually look at this here, alright, so if we see, alright, so the default gateway, we see, right, that's going to be device ID 1, which we can see here. And when it says, gateway, now if you remember, alright, so the gateway, alright, so let's say, that's the entry and exit point to the network. Now on, let's say, a home network, right, the entry and exit point to the network, that's just going to be the router. So when it says default gateway, so when it says default gateway, the default gateway is, basically just the router. Right, so what's going to happen, right, I think we mentioned this already, alright, so hopefully you remember when we said packet switching. So a router is going to inspect the destination IP address of each incoming packet in its routing table, and it's going to forward the packet onto the next best hop. So if it sees, I don't know, alright, so if it sees an IP address of like, 200, 200, 200, 200, well, then it's going to look at the routing table, and it says, well, if I see an IP address, within that range, right, alright, so then it's going to say, well, what device should I then send it to? Right, then it's just going to send it, to the next router, right, alright, so that router is then going to look in its routing table, right, again, it's going to check, well, 200, 200, 200, right, etc. Alright, so then it's just going to send to the next router, right, so on, until it gets to the final router, and, alright, so in that case, well, then it's actually, reached the target network, and of course, well, that router can then, send it to the device that's kind of on that network. Right, okay, so yeah, alright, so if we look at this, well, we said that part of an IP address represents the network, right, the network ID, right, well, part of the IP address represents, well, device ID, and traditionally there's been three ways used to achieve this. So the first one, well, IP classes, again, like not used since 1993, I think we say. Right, then, well, classless interdomain routing, right, CIDR, and finally subnetting, and again, subnetting, well, that's what's used today. Right, so if we look at the first one, and again, as mentioned, right, don't really exist anymore and have been deprecated since 1993. However, they are still in the book because I guess, so I guess the reason they want you to learn about them is because, well, so basically, since we see the problem of this, well, so since we see the problem of, IP classes, well, that's then going to inform the reason of, why, for example, CIDR and subnetting were, eventually developed, just to solve these problems. Right, so what we can say then, alright, so basically it's going to be three different types of IP addresses, well, Class A, Class B, Class C. Now, if the IP address starts with a 0, well, then it means that it's getting, so if the IP address starts with a 0, well, then it's going to be in this format. And what that means, so the next 7 bits are going to represent the network ID, right, and the final 24 bits, here we are, so the final 24 bits, well, they're going to be the host ID, the device ID. And if you actually think about that, well, that's going to add up to 32 bits, because if we see here, well, so if we just have 0, well, 0 is going to be 1 bit. Obviously, well, here that's 7 bits, right here, well, 24 bits. Right, so yeah, 1 plus 7 plus 24, right, that's going to be 32. Likewise, if alright, so if we look at the next one, Class B, well, Class B, and yeah, where's the pen? Here we go. Alright, so Class B, well, that's using 2 bits, right, to represent what class it is. Right, okay, then what? The next 14 bits are for the network, right, the next 16 for the host ID. Again, if you add all those up, right, that's going to be 32. And likewise, Class C, well, Class C, right, 3 bits for the class identifier. Alright, 21, and then, yeah, 8 for the host. Again, right, add those up, it's going to be 32. So to see an example, well, let's say this is our, so if this is our IP address, well, since here it starts, right, 110, well, therefore we know it's going to be Class C. And since it's Class C, well, therefore we know what the next 21 bits are going to be the network ID, right, and the final, so the final 8 bits, right, they're therefore going to be the host ID, or yeah, the device. And, alright, yeah, what class will this be? Well, I think here we've said that already. Right, so let's think then, why do we need up to 3 bits for the class identifier, right? Why can't we just say, I know, Class A is 0, Class B is 1, and Class C is 0, 1? So again, you can pause the video or have a think about that if you want. Okay, so the reason for this, well, basically it's just going to be to prevent so to prevent ambiguity. So i.e., if an IP started 0, 1, well, we actually wouldn't know, right, if either that's going to be a Class A because, Class A is 0, or, is it just, Class C like this? So, yeah, so that's, so that's why they choose, these 3 kind of bit patterns, since you're never going to get, like, so you're never going to get an ambiguous bit pattern, that could be 2 different classes. So let's also have a recap question, and this is kind of completely, unrelated to networking, really. This is going to be Unit 1. But what text compression technique do we also need, to make sure that patterns start with a unique series of bits? So again, you can pause if you want. Alright, so hopefully people remember this was going to be Huffman coding, because if we think, well, Huffman coding, basically what each character is going to be right, let's say each Huffman code is generated in a way that you're never going to have, you know, a kind of ambiguous decoding. Yeah, it's always going to be unique. Right, so just to see that, well, I guess this screenshot from some video, yeah, I can't remember what video this is, but again, it's just kind of saying the same thing, right? It starts with 0, 7 bits for the network ID, right? 24 bits for the host ID, right? Again, likewise for B and C. Yeah, you can, you know, pause the video, have a look at that if you want. Right, okay, so let's think then, alright, so since each IP address has to be unique, then how many different network IDs are there in Class A? So hopefully people realise the way we can do that well. Alright, so if we look here at the table, well, Class A is using 7 bits, right? Therefore, we just go 2 to the power of 7. So that means there's only 128 different Class A networks. And that's, yeah, okay, alright, so that's going to be in the entire world. Now, when you think, well, you're going to have governments, I mean, well, again, you're going to have militaries, right? You're going to have, well, you have obviously, you know, huge companies, right? Now, probably some of those, you know, big companies, governments, well, yeah, okay, alright, so they're going to want some of these Class A, you know, IP, right, okay, alright, so they're going to want these Class A networks, but since there's only 128, well, yeah, of course, right, therefore there's not enough. Right, however, I guess the good thing about it, well, Class A network could have, well, 16 million, right, you know, 777,000, right, different devices. And the reason for that, well, because obviously here, right, 2 to the power of 24. However, we'll actually see in a minute that this is actually a bit of a problem because, well, let's say you have, I don't know, a company, and, right, this company only needs, you know, let's say 1 million different devices. Well, then what you've effectively got, well, all right, yeah, okay, all right. So then basically what you're going to have, well, if they've got a Class A network, well, then you've just got, you know, what, 15,777,000, right, just wasted IP addresses. So, right, if we go next, right, let's just look then the number of network IDs and the device IDs for the, well, you know, 3 different classes. Again, well, pause the video, have a look at that. But again, I mean, it should make sense here if we just go back, right, thinking about the number of bits. So yeah, 2 to the power of the number of bits, right, for each of these. So if we think, well, can you, right, yeah, again, so you can pause the video if you want. Right, can you think of any problems with this allocation? And I'll give you a hint. Let's think about, for example, this one. And I guess, yeah, all right, okay, all right, yeah, all right. So I guess also this one as well, to be honest. Right, so as noted, well, there's only 128 Class A networks. So again, you know, for governments, militaries, you know, big companies, right, that's not going to be enough. Right, I guess a bigger issue, well, there's only, what, 16,000, right, 384 different Class Bs that can exist. Now, if you're, let's say, what, like a medium to kind of semi-large business, right, if you're a school or hospital, yeah, and then maybe like an airport, right, things like that, well, I mean, they're going to want this class because, yeah, okay, all right. So if you think, well, 256 devices is not going to be enough, you know, for a school, right, for a business. So yeah, right, okay, all right, so that means what they're going to want, well, they're going to want this one, but, you know, right, again, right, there's only 16,000 in the entire world. I guess you can also say, to be honest, right, yeah, okay, all right, okay, so also for home users. Now, here we've only got like 2 million, all right, yeah, okay, all right, so we've only got 2 million Class C, you know, networks. But if you think, well, think how many homes have a router. Now, I mean, what, there's probably like, what, I don't know, yeah, all right, okay, so probably like 500 million homes, right, maybe even 1 billion homes with a router. So again, you know, that 2 million is obviously nowhere near enough. Right, there's also a problem. Well, let's say a company has, you know, 257 devices. Right, I guess really there's 2 things that can happen. Well, either they could buy, you know, 2 Class Cs, but then this actually makes configuration difficult because what you have to do, well, then you have to ensure that, let's say, a device on, you know, one of the networks is able to communicate with one of the devices on the other network. And if you've got, say, I don't know, like some file server, yeah, you've got to make sure that, you know, right, okay, all right. So you've got to set up the permissions so that it's going to, you know, allow connection from both networks, yeah, etc. So I guess that's going to be a bit tricky, right? Just, you know, setting up that configuration. So what people would do, well, they'd often simply buy a Class B. However, then you have the problem, well, then they have, you know, 65,000 addresses. Well, yeah, in particular, well, 65,000, you know, 536 addresses. Yeah, and I guess, well, most of those are going to be unused since what they're only using, right, this many, right, of those addresses. And since, yeah, okay, all right, so since we only have, you know, 4.3 billion IP addresses in the world, right, if someone has this, you know, 257 being used, right, out of, you know, 65,000, well, that means what, I mean, probably what, more than 99% are unused. So yeah, of course, right, okay. So that's going to be, extremely wasteful. Right, so something that you could do, and this is kind of going on to subnetting really. So suppose a small company has 150 computers, but you want them on 7 different LANs. For example, maybe they're in a different building, right, different departments. You have like a finance department, research department, right, customer service department, and each of them you want to be on a different network. So in this case, well, then they would need to buy 7 Class C networks, which would mean, well, I guess 17,092 addresses. But again, since they've only got 150 devices, then 1,642 of those addresses are wasted. All right, so okay. So this is not really talking about subnetting yet, although we'll see that subnetting can be used to solve this problem. And yeah, I guess we'll see that later. Right, so if we look here then, unused device IDs. Right, so to try and solve this problem of wasted IP addresses, right, with a class-based IP system, right, then a new approach was introduced, and that's going to be classless interdomain routing, or CIDR. Right, so yeah, this aims to solve the problem of the inflexible split, i.e. only 3 classes between the network ID and host ID, or device ID. Right, so it's going to add an 8-bit suffix to the IP. So when it says suffix, well, basically just something at the end. And if you see here, right, okay. So this is going to be the suffix. So what this actually means, well, now the IP address is actually going to be 40 bits. Since we've got this extra suffix. Right, so these, right, okay, all right. Okay, so let's say, so let's say the IP address is still, 32 bits, but I guess you're kind of sending this, 8-bit of kind of metadata. So so I wouldn't really say the IP address is 40 bits, it's just, 32 bits, right, plus, an extra 8 bits of metadata. Right, anyway, these suffixes specify how many bits for the network ID. Right, the remaining bits, right, of the 32-bit IPv4 address, right, would therefore be for the host ID. So, for example, well, since here we see 21, and yeah, where is the pen? Okay, here we go. All right, all right. So since we see 21 here, well, what that means is it means, well, 21 bits are for the network ID, right? Hence, 11 again be for the host ID. Since if we think, 32 bits total, right? Therefore, 32 minus 21, right? Since 21 for the network. Right, all right, okay, so that's going to mean 11 remaining, right, for the host ID. Right, and also CIDR also doesn't waste, the first 1 to 3 bits for specifying the class, right, saying, class A, class B, class C. So yeah, that's also going to be better. Right, however, CIDR IP addresses are also compatible with the original class-based IP system, and we can do that by simply setting the suffix, to 8, 16, or 24 respectively. Because if you actually look at this, well, if we have the class identifier, well, this is going to be 1 bit and then plus 7, right? So that's going to be 8 bits. If we look at the, this sort of first part, right? Then if we look at the next part, so B, all right. So this is going to be 2 bits plus 14. So that's going to be 16. Then all right. So for class C, well, that's 3 bits plus 21. Right? All right. So that's going to be 24. So hopefully that's how you can see, so if we set the, so if we set the suffix to, 8, 16, or 24, so as we can see here, then if we set the suffix, right, to, 8, 16, 24, right, then effectively we can just create something that's equivalent to class A, class B, class C. But yeah, we can do that using CIDR notation instead. Right, and I think here this just kind of says the same thing. So for example, if we want class C, well, since that uses 3 bits, right, to specify the class, right, 110 as the class identifier, right, then what we can do, well, we can keep the 21-bit net ID the same and just set the leading 3 bits to 0, because if we set the leading 3 bits to 0, well, then if we're thinking about binary, unless we obviously 1, 2, 4, 8, 16, right, etc. Well, all right. So if we start with 0, 0, 0, well, then of course it's not going to change the actual value. So hopefully that makes sense. All right, all right, so finally then it's just going to be subnetting, and all right, so again, this is what's used today. Right, another approach here, the one currently used today, right, so here you can run, for example, ipconfig/all. Now this is on Windows, right, so if you, so if you're on Windows, if you just open terminal, right, command prompt, I guess, PowerShell they call it now, right, if you just type in ipconfig, right, space, and then /all, well, then you're going to get all of this information. yeah, just about the various, well, I guess, yeah, sort of, well, network cards, right, things like that. Right, and we can also see the subnet mask for the network. So yeah, let me actually just erase that. And let's try and sort of highlight the important information. Now, if we look at the first one, well, description, right, real tech, I guess I don't know, some sort of probably version number, right, something like that. Right, I guess saying Wi-Fi. Now, if we think back, okay, this is going to specify the Wi-Fi protocol. Right, this AX, well, I think AX, right, is just sort of different, yeah, different versions, right, different variations. Right, this 802.11, well, this is just the, I guess, the sort of code for Wi-Fi. Yeah, the sort of specification code for Wi-Fi. But basically when it says this, well, right, okay, alright. So when it says this, well, this is going to be the network interface card. Now, in particular, yeah, okay, alright. So since this is, well, wireless, right, okay, so this is going to be the WNIC, right, the wireless network interface card. If we were looking at, I guess, what the Ethernet adapter, well, the Ethernet adapter, well, then it's going to be the network interface card. Right, okay, so when it says physical address, well, physical address just means MAC address. Yeah, I think MAC address maybe we looked at in a previous video, I can't remember. If we've not, then we'll look at it later in this series. Right, DHCP, alright, okay, alright, so DHCP, well, the Dynamic Host Control Protocol. Now, again, that's going to be used for kind of getting dynamic, well, yeah, okay, alright, so that's going to be used for, right, okay, so that's going to be used for the device to request a dynamic IP address, yeah, well, from the DHCP server, right, either, well, the router, right, or the ISP's DHCP server. I mean, auto configuration, yeah, not really sure what that's going to specify. I mean, here, if we just see, well, yeah, IP version 6 address or IP version 4 address, and if we see, well, IP version 4 at 192.168.1, right, yeah, 109. So if we think, well, 192.168.1, right, that's going to be a private IP, and I think this we'll probably look at as well. There's going to be certain range of IP addresses that are private. So I think anything that starts, yeah, okay, alright, okay, so I think this, right, 192, right, .168, let's say, I don't know, yeah, .n, right, .n. So right, okay, alright, yeah, so anything that starts 192.168, right, that's going to be a private IP. So basically, yeah, just within that LAN. I think there's also other, yeah, okay, alright, so there's also other private IP address ranges. I think one of them is maybe like 10n.n. Yeah, like maybe that's correct, maybe that's wrong. I think there's also one or two other private IP ranges. Alright, anyway, the important thing to look here then, right, is going to be the subnet mask. So when we say the subnet mask, well, 255.255.255.0, then what that means, well, if we see a 1, and, right, okay, alright, yeah, okay, so when I say 1, well, alright, yeah, okay, so that's 1 in binary. Now, if you think, well, 255 in binary, right, okay, alright, so 255 in binary is just going to be 8 ones. So effectively, well, this subnet mask, what that's going to be, well, right, okay, alright, so it's going to be 24 ones, and then if we think here, just 0, right, yeah, okay, alright, so finally, well, then it's just going to be, 8 zeros. So what that's saying, if we have a 1 in the subnet mask, well, then it means it's specifying that it's, part of the network ID, right, whereas if we see a 0, well, then it means, it's the device ID. So in this case, well, since we have, right, 255.255.255, then what that actually means, right, okay, alright, so that means the first 24 bits are going to be the network, right, and then, yeah, right, okay, so here, right, the last 8 bits, well, that's going to be for the device ID. Right, this thing, well, lease obtained, lease expires, right, that's going to be DHCP. Yeah, I think don't worry about that at the moment. Right, again, the default gateway, well, just the, right, okay, alright, so the default gateway, well, yeah, right, okay, so as mentioned, that's going to be the IP address of the router. And if you look, that should actually be, yeah, okay, alright, so if we see, well, 192.168.1, so our IP address is actually on the same network, right, as the router. And yeah, well, yeah, right, okay, alright, so, I mean, hopefully that makes sense, right, why that has to be, yeah, why, our device has to, yeah, be on the same network as the router. Likewise, the DHCP server, well, if we see the DHCP server, right, okay, that's the same address as the gateway. And hopefully that makes sense as well, because if you've seen the previous videos, then hopefully you remember that, alright, okay, alright, yeah, alright. So if we say a home router, well, a home router doesn't only perform, the function of being a router, right? It's also going to perform the function of, well, being a gateway, right? It's also going to perform the function of, DHCP. If we look here, okay, right, it's also going to perform the function of, well, yeah, sort of handling DNS requests. So DNS request, right, okay, alright, so DNS request, well, that's going to take a domain name, right, for example, well, yeah, google.com, right, then it's just going to convert that, or yeah, I guess I kind of look up the IP address, right, that corresponds to that domain name. Yeah, all right. So again, there's kind of quite a lot of information there, but I think now, you know, after doing this unit, yeah, people should be familiar with most of it. And even if you're not currently, because well, DHCP DNS, right, that's going to come in later videos. All right, anyway, let's see how it works, and I think really we just kind of explain this. Right, so again, 32-bit IPv4 address, right, split into a network ID, host ID. Right, a subnet mask is used to determine if a bit corresponds to the network, right, well, yeah, kind of network ID or host ID. Right, a 1 means it corresponds to the network, right, a 0 means it corresponds to the host. So, for example, a subnet mask, yeah, 255.255.0. Right, okay, all right, so what that means, well, 24 bits are for the network ID, right, since we've got, well, 24 ones. Therefore, the remaining 8 bits are going to be for the host ID. So let's say an IP, well, 70.152.34.55. Right, that means the network, well, since we have what, yeah, okay, all right. So since the first 24 bits of the network, right, that means, well, the network is what, 70.152.34, right, yeah, okay, all right, okay, so the last 8 bits are going to be for the device, yeah, for the device, or yeah, well, host ID, right, therefore, well, that's going to be at device 55, right, on that network. And I think maybe it says, no, yeah, wait, maybe. Alright, so I was going to ask, well, if you think about this, yeah, okay, alright, so if, okay, so if we have a subnet mask like this, then try to think how many different devices we can actually have, you know, on that network. So if you've had to think about that, well, hopefully you can realise, since we're using 8 bits for the host ID, well, then that's going to be 2 to the power of 8, right, or 256 different devices. So again, you know, right, okay, so let's say for like a home, or, you know, I don't know, maybe a classroom, well, that's probably going to be enough. But if, for example, you look at, right, okay, all right, so if you look at, say, your subnet mask, right, for your entire school, well, your entire school is probably going to be using, right, this subnet mask, so 255.255, right, .0.0, because, well, if we think about this, well, right, okay, all right, so then we're going to have, well, 2 to the 16, right, different devices. And well, I think again was like what, 65.536. Yeah, I think something like that. Right, so yeah, common subnet masks are, well, those two. So I guess well, yeah, here just 0, and then well, here, right, 2 zeros. Right, the first is much more common worldwide than the latter, and right, why do you think that is? So let's say, why is this one more common? Yeah, throughout the entire world, and think about what I've just mentioned, right, in terms of how many devices this will, you know, support. Right, so the first subnet mask provides 8 bits for the host ID, right, i.e. 256 devices, right, while the latter, well, 16 bits for the host ID, right, 65,000 devices. So other than, well, again, you know, sort of fairly big companies, governments, right, most people, right, e.g., yeah, just for home use, or yeah, maybe small office use, well, they're not going to need networks with like 65,000 different devices. Right, therefore, using an 8-bit host ID, right, okay, alright, so using an 8-bit host ID, well, 1, it's going to be sufficient. Right, and 2, it also means we can have more networks, right, since that means, well, 24 bits is still available for the network ID. Whereas if you had it where, right, yeah, okay, alright, so let's say if everyone was having networks like this, where you had, you know, 16, yeah, okay, alright, okay, so if you had, right, okay, alright, so if everyone had networks like this, where you have, what, 16 bits for the host, right, 16 bits for the network, well, what that means is that worldwide you're going to be able to have less of those networks, right, compared to, for example, this, yeah, where you have, what, like 2 to the power of 24, right, yeah, different networks available. Alright, so this is similar to the other photo, or yeah, other picture. Right, so subnetting, well, this is used to break a big network into multiple smaller subnets. Right, okay, so for example, well, imagine you're a company, and again, you have different departments. Yeah, alright, so, okay, so I guess if it's a LAN, I mean, you can probably say switch. To be honest, I think here, like, yeah, alright, so let's actually say router. Yeah, alright, and the reason I'm going to say router is because, well, if, right, okay, so if one subnet has to communicate with, with, you know, another subnet, well, then it's going to have to be a router. If you only need a sort of LAN, you know, that's just communicating just with other devices on that LAN, well, yeah, okay, alright, so then you can just use a switch. But as soon as you want to go, you know, outside of that LAN, well, then you're going to need a router. Alright, so anyway, for example, well, you may not want the customer service department to be on the same network as like the research and development department, yeah, for sort of various, well, security reasons, or like data privacy reasons. even if they get hacked. Well, let's say the customer service department gets hacked. Well, if you have good sort of network separation, then hopefully the hackers wouldn't be able to go from that network, onto the sort of research network. Or likewise vice versa, right? If they get on the research network, well, you probably don't want them going on the customer service department network, since maybe that has, some sort of personal customer details, right? Like, name, telephone number, all right, maybe even, banking details. Right, so for example then, suppose we have 8 bits for the host ID, we could then use 3 of these 8 bits to represent the subnet and 5 bits to represent a device. Right, if we did that, well, that would then give us 8 networks, and the reason it gives us 8 networks, well, if we think 2 to the power of 3, right, so 2 to the power of 3, since we're using 3 bits for the network, well, the subnet, right, and it's therefore going to give us, 32 bits, no, well, okay, alright, so not 32 bits, right, 32 devices, right, on each of the networks, since, 2 to the power of 5, right, that's going to be 32. Yeah, so hopefully that makes sense why we would want to do that, because maybe right, okay, alright, so maybe we have LANs in different locations. Again, maybe you want to sort of separate out the customer service department, from the research department, right, etc. Rather than just having one big LAN, right, with 256 devices. So I think sometimes people get confused about what subnetting is, but if you actually think about it, well, if you think sub, what sub just means to kind of break down something, or I don't know, like a subcategory, right, to split something. And obviously net, well, just a sort of collection of devices that are communicating together. So what, right, okay, okay, so what you say, well, it's basically taking one big network and just, breaking it down into sort of multiple smaller networks. Alright, so here then we can see, if the subnet mask changes, right, what actually happens to the number of networks and number of hosts available. So if, for example, we have here 0, well, that means there's only going to be one network. Right, okay, alright, but there's going to be 254 different hosts. Now, the reason they don't say 256, because if we think 2 to the power of 8 is 256, technically 2 of those, okay, so 2 of those so 2 of those were host IDs, right, they're going to be reserved. And usually the ones that are reserved, well, one is going to be the smallest, right, which is 0, and right, alright, so it's also usually going to be the biggest. Right now, the biggest they actually call the broadcast address. Right now, to be honest, this is not required for A level. So if you just say, alright. So if it asked you and you say, well, there's 2 to the power of 8 or 256 different addresses available, or like different hosts available, well, that's going to be sufficient, right? Even though, I guess in reality, again, 2 of them are going to be sort of reserved, right? They're unusable. Likewise, if we look at this, right, so here then, if we say 1 bit is for the subnet, right, therefore, 2 to the power of 1, right, okay, so 2 to the power of 1 is 2, right, the remaining 7 bits, well, that's going to be, 2 to the power of 7, 128, but again, right, minus 2, I guess that's to 126, just etc. And if we look, well, this one, of course, is going to be 254, since, well, this, alright, so these 7 bits are going to be 254, and then, well, of course, this just the sort of 1 at the end. Alright, so again, another screenshot, and this guy, he actually has quite good quite good videos. I think mostly they're for the CCNA, which is like maybe Cisco certificate, network something, like a professional networking certificate. So to be honest, these videos are going to be more detailed, but if you do want to look at this, this is also a good channel. And I think there's also some others. One is called like Power Sir Animated Videos. They have a lot of good networking videos. There's also, I think they're called SERP Bros. SERP Bros also have good videos. But if we look, so this actually just shows the same thing, but just the different ranges. So if we have one subnet, well, that means 0 to 255 is available. Obviously 2 subnets, well, right, okay. So 2 subnets, well, okay, so the first subnet is going to be the host ID is 0 to 127. Right, the next subnet is going to have, of course, what the host ID is, right, 128 to 255. And likewise, by breaking it down to 4 subnet, 8 subnets. So hopefully that makes sense. Right, so this is another advantage, same as CIDR, classless interdomain routing. The subnet mask also doesn't have to be split at positions, 8, 16, or 24. Suppose we have a network that will have a maximum of 1,000 devices. Then how many bits should we use for the network ID, right, and how many bits therefore should be remaining for the host ID? And if we think about that, well, hence what would then be the subnet mask. So the way we want to calculate this, and again, I would say pause the video, right, if you can try and do this yourself. Now, the way we want to calculate this, well, basically we want to think, right, so 2 to the power of what is going to be, greater than 1000. So I guess kind of this, right, 2 to the power n is greater than 1000. I guess if you were to do that in maths, I mean, honestly, alright, so my maths is really bad, but I think if you did log base n of 1000, and then I guess what you would then want to floor that, not floor it, so you'd want to do ceiling, right, just rounding up. Now, if you do that, to be honest, like, you might actually remember, 2 to the power of 10, that's going to be like kibbe. So yes, kibbe bits, kibbe bytes. So that's going to be 1024. So in this case, what we're saying then, so we're saying, 10 bits will be for the host ID, right? Therefore, 22 bits are going to be for the network ID. So effectively, what that means, so if we're so if we're writing CIDR, so CIDR notation is going to be /22. Right. However, so if we're writing it as a subnet mask, a subnet mask, so that's going to be 22 ones. And then 22. Then finally, it's just going to be 10 zeros at the end. Now, to be honest, this you'd have to add them up. So I guess 22. If we think, that's going to be 255, 255, right, for the first 16. Right. Then I guess you're going to have 6 bits. So yeah, I mean 6 ones, whatever that's going to be, 128 plus 64 plus 32 plus 16, plus 8 plus 4, so I guess whatever that's going to be. Alright, so let's just have a look at that, right? If you had that, right, that's going to be 255, 255, right, 252, and then 0 at the end. And I'm just going to erase that, but I think hopefully people can see this, and hopefully people can understand, right, how we've arrived at that. Right, so suppose we have the IP address, 27.78.103.250, and subnet mask, like we saw, 255.255.252.0. Then let's think, what is going to be the network ID and host ID? And to be honest, I guess here this is kind of animated in the wrong order. Yeah, we can see this already. So if we think, so if we write the IP address, 27.78, right, 103.255, here. So for example, so this one's 27. Right, this is 78, this is 103, and this is 250. Now, if we then write down this subnet mask, then what we can say, so let's say all of these bits are going to be for the network, and, so all of these bits here, they're going to be for the host. So if you actually write that in denary, then effectively you're saying, so the network is kind of, 27, right, 0.78, right, sort of, 0.100. Right, and the device ID, it's kind of like this, right, like 1018. But the thing is, so if we look here, now if we're using, so if we're using, 22 bits for the network ID, then actually what's going to happen, so let's say, so the real network ID, let's say not the network ID, let's say the network range that we would own, that's going to be, I don't know, like 22, right, 0.78, right, 0.100, right, probably, 2, let's say, I don't know, 27, right, 0.78, and I think maybe like 103 might be the maximum. So in this case, so hopefully, as you can see, in this case we're actually going to own kind of a range of networks, right? It's not just sort of one sort of static number. And I'll actually show in a minute. There's actually a website. Alright. So actually, so there's many websites we can use to calculate this, but I've just linked one of them in a minute. Right. So I guess things can get a bit complex for humans, if the subnet mask doesn't split kind of nicely on an 8-bit boundary. However, I mean, as you can see, hopefully you can see how we do this. If we just write out the IP in binary, write out the subnet mask in binary. Of course, we'll just split them, based on that boundary. And then, just calculate the sort of denary values of each. Alright, so actually this is going to be the website I was showing then. So if you want to have a go at this, was IPTP, right, .net, and just IP calculator. So here, for example, if you type in the IP address, alright, so like for example this one, right, then if you, for example, choose the subnet, right, so if you see here, so, this is the IP address we've entered, right, the network address, so the network address, it's going to start from, 27.78.100, right, if we see the range, so the range we can see here on this one, and yeah, as we see, well, that's going to go up to what sort of network ID 103. And as mentioned, well, since 0 is going to be taken, yeah, it's kind of unusable. Right, that's then going to go, well, from 1 right up until, well, 254, because again, 255 is going to be the broadcast address. And yeah, that okay, yeah, okay, here we go. Right, so yeah, right, yeah, okay, so that's what it says there. Right, then it also tells us the total number of hosts, right, 1024, right, number of usable hosts, again, 2 of them taken. Right, it's going to tell us the subnet mask. I mean, this wildcard mask, don't worry. Basically, wildcard mask, alright, okay, so the wildcard mask is just, well, the inverted subnet mask. So rather than it being sort of 1, which means a, alright, yeah, okay, alright, okay, so rather than it being a 1, which means the network ID, right, it's going to be what, a 0 is the network ID, right, and yeah, a 1 is going to be the device ID, right, so yeah, just inverted. Yeah, and well, right, okay, alright, so again, yeah, okay, so again, okay, that can also tell you the CIDR notation, right, equivalent, yeah, and also whether it's, you know, public or private IP. Right, okay, so let's try this. So let's say here we have the IP address, right, 192.168.1.0, and hopefully, again, you remember that should be a private IP. Now, if we're saying /24, then let's think, what would the equivalent subnet mask be of this? And if we say /24, well, remember, right, okay, alright, so /24 means, well, CIDR notation, right, classless interdomain routing. So hopefully you realize, well, the subnet mask is what, 255, 255, 2550, because, well, 24 ones, right, then just 8 zeros at the end. Right, okay, so let's think then, right, would this IP address be valid for this network? So if you've had to think, well, right, this is going to be no. Right, since the first 24 bits for the network ID, right, and yeah, right, okay, yeah, alright, so hence they're not going to change. Yeah, alright, so that's probably not a good explanation. Right, okay, alright, yeah, okay, so basically the problem here, well, right, okay, so since this is a 2, right, but this is a 1, now since we're saying, well, the first 24 bits are all for the network ID, right, therefore they should always be, you know, 192.168.1. But yeah, since here we've got a 2, well, right, yeah, okay, right, so 2, of course, is going to be a different network. Right, but let's try this one, so 192.168.1.2. So yeah, hopefully you can realize this is going to be valid, because if we look here, well, the first 24 bits, yeah, well, they're, yeah, okay, alright, so the first 24 bits, right, they're going to be the same as the network ID here, right, and then, well, of course, this 2, right, that's just going to be, well, the, yeah, host ID, right, device ID. Alright, so I think the final thing, let's have a look at the advantages and disadvantages of subnet masks. Well, yeah, right, okay, alright, so I guess not subnet masks, but, you know, kind of subnetting, right, breaking down a network, right, into multiple subnetworks. So one is going to allow greater utilization of IP space, right, less wasted IP addresses. Alright, so I thought maybe it'd explain why. Right, hopefully people can figure out, or yeah, hopefully people remember. Now, the reason for that is, well, right, yeah, okay, so if we compare this, you know, with the original IP class-based system, now what you had, Class A, Class B, Class C, now let's say if someone wants, you know, 257 devices, well, 257 devices, what, yeah, okay, alright, so 257 devices, what, they're going to have to buy a Class B, right, or, you know, multiple Class Cs. However, yeah, probably realistically, right, so, you know, often people are just going to buy the bigger one. So if they buy Class B, well, Class B had, what, like 65,000 approximately, right? Therefore, well, effectively, what, 65,000 addresses are going to be wasted. Whereas if we think subnetting, well, right, okay, alright, so if we have 257 different devices, well, 8 bits is not going to be enough, right? Therefore, if we use 9 bits for the host ID, well, that's going to be, what, I guess 512. Although I suppose what you could say 510, right, since, yeah, 2 are unavailable. So in that case, what, right, yeah, okay, alright, okay, so if we're saying, right, 9 bits for the host ID, well, that's therefore going to be, what, 23 bits for the network ID. So yeah, I guess, alright, yeah, okay, alright, so, yeah, so in that case, the subnet mask is going to be, what, 23 ones, right, followed by 9 zeros. Right, it's also going to make the network easier to organize and maintain, right, for large networks, because I guess if there's some sort of problem, well, if you have, you know, thousands of devices, right, it's going to be kind of impossible to figure out, you know, what device has a problem. Yeah, I guess, I don't know, you know, what wire is broken or something. Also, if you have any suspicious activity, again, if you have thousands of devices, all sending like gigabytes and gigabytes of data, backwards and forwards, well, it's going to be sort of difficult to kind of filter out that and to actually figure out what device is the one sending the suspicious packets. So yeah, all right, okay. So here, I guess we can say, well, it's going to be easier to organize and maintain, if we break a large network into multiple smaller networks. However, I guess maybe a slight negative. Well, you do require the initial expertise to actually set that up. Now, to be honest, I've never actually tried to set up, sort of multiple subnets like this. I guess, just for normal people, I mean, you're not going to need to, right, if you just have like a home router. But let's say if you're like the network administrator at a school or at a business, well, yeah, okay, all right, so then I guess you'd have to do this. Right, it's also going to improve security because, well, you can have, for example, different firewall rules at different levels of security based on the subnet. So again, if you have some super, top secret research, well, you're probably going to want to have, really strict firewall rules. Whereas if, for example, you're just talking, right, okay, all right, yeah, okay, so if you've got another network which have, say, like a web server, well, in that case, you're probably not going to want overly strict firewall rules, because if the rules are overly strict, well, then it means that people trying to access your website. Yeah, okay, all right. So then it means people trying to access your website are just going to get blocked. Kind of like unintentionally blocked. So something like a web server, of course, well, you're going to want less strict firewall rules. Compared to other things. Yeah, I guess also, well, different levels of permission, right? Different levels of access rights. Right, network separation. So again, well, different departments, right? Finance, research, right? Customer service. Right, so they can be on different subnets, right? Hence, they won't have access to the other network or other files. And again, well, that can be good for security, right? Good for privacy. So yeah, check in that, let's say, someone working in one department can't, for example, see the personal data of some customer. Right, also hackers and malware can also hopefully be contained to a single subnet. So if you have, I don't know, like 8 subnets, and let's say one of the subnets gets infected with some sort of malware, well, hopefully if you have sort of good containment, right, good firewall, good security, well, hopefully that malware won't be able to spread onto the other subnets. Right, it's also going to improve efficiency by breaking down, well, big busy networks into lots of smaller subnets. All right, and okay, all right. So the reason it's going to improve efficiency is because, well, you're not going to have, let's say, one router which has like thousands of devices communicating with it, because of course, well, if you had that, it's going to be slow. Whereas if you break that down into, I don't know, let's say 20 small networks, well, yeah, then right, okay, all right. So then it's going to be more expensive. Yeah, okay, all right, okay. So it's going to be more expensive because, well, then you need 20 routers. However, I guess really, routers are cheap, and for a company, for a hospital, for a school, I mean, the cost of a router, compared to the cost of, I don't know, some new like medical equipment is just kind of insignificant, really. So I think that's not really an issue. Let's finish by having a look at some questions then. So, right, first we want to see, well, what do the letters IP stand for? And as always, well, just pause the video, have a think about this, or have a go. So if you've done that, well, IP, right, is just going to be Internet Protocol. Right, then let's think, well, what is an IP address used for? Again, right, pause, have a go. Okay, so we can say, well, all right, so it's to uniquely identify a device on a network, right, hence allowing it to receive packets, right, or communicate, well, with other devices via a series of routers. And hopefully people remember, well, this really is just packet switching, where you have, well, right, okay, all right, yeah, okay, so, right, yeah, so let's say the device will send the packets to the router. The router will then inspect the destination IP address, of each packet. It's then going to look in its routing table, and basically it's going to compare the destination. Yeah, okay, all right. So it's going to compare the destination IP address, with the IP address ranges in its routing table. When it, yeah, okay, right, okay. So when it finds the correct IP address range, that this packet is intended for, well, then it's going to send it, to the next router. Right, specified by, well, yeah, okay, all right, okay. So it's going to send it to the next router, that's kind of mapped to, sort of, well, by the IP address range, right, in the routing table. Yeah, I mean, hopefully that makes sense. I did actually kind of explain that in a previous video, but yeah, I mean, yeah, all right, okay. So yeah, hopefully that makes sense. And if it doesn't, I would say just look up, IP routing tables, for sort of more details. Right, anyway, the next one, so an IP address consists of 2 parts, right, a something and something. So I think we mentioned this many times in the video, right, network ID, host ID. Right, then we want to describe the format of an IPv4 address, and this is a typical question they ask in the exams. Right, so first we say, well, it's going to be 32 bits, right? There's also 4 groups, and, well, okay, so 4 groups, and each group is going to be 8 bits. Right, each group can be represented by a denary number 0 to 255, and finally, groups have to be separated by, well, dot, full stop, period. Just the, well, yeah, I guess that character in red. Right, okay, then we want to state whether these IPv4 addresses are valid, and if invalid, then give a reason. And again, yeah, this is also a typical exam question. Right, so the first one, well, if we remember, the range is going to be 0 to 255, right, for each group, but here there's a 328. So yeah, invalid, well, 328 is greater than 255, right, which is the maximum allowed value, right, for, for each group. Right, then if we look at the next one, so again, yeah, have a think. Okay, so this one's going to be valid because if we think, well, there's 4 groups, they're separated by a dot, and each group is between 0 and 255. Right, then look at the next one again. Yeah, pause the video if you need to. So I think here you can count how many groups, and if you count, well, invalid, right, there's 5 groups, not 4. And finally, yeah, this one. Right, so hopefully people realise that's invalid because, well, if you look at the separator, okay, so this one's using a colon as a separator, right, rather than the full stop. Now, IP version 6 will use the colon. Right, MAC addresses, well, alright, so MAC addresses can either use a colon, right, or they can use a hyphen. Yeah, both of those are accepted, let's say, I know, yeah, AA, right, BB, or I guess, well, AA, obviously, yeah, BB, like that. Now, okay, so MAC addresses, well, they're going to be, what, 12 hexadecimal digits, so of course, yeah, right, okay, so that's just going to be, expanded. Yeah, that's just a simple example. Right, so let's think then, right, okay, so what 3 approaches were used to break an IP address down into the network ID and host ID? Yeah, starting from what the old one from 1993, going up to what's used today. Right, so IP classes again were old, right? Well, 1993. It was deprecated in 1993. Right, okay. Then there's classless interdomain routing, right? CIDR. And hopefully you remember what CIDR, what that. Right, okay. All right. So CIDR, okay, basically just using the slash notation. We're adding this 8-bit so adding this 8-bit suffix right at the end of the IP address. Just to specify how many bits are going to be for the network ID or how many bits for the device ID or host ID. And then subnetting. Now subnetting, alright. So subnetting, just adding the subnet mask, basically to do the same thing as CIDR, in terms of specifying how many bits for the network ID, how many bits for the host ID. Although subnetting does also provide the additional advantage that not only can we just kind of specify, well, we can actually take a network and break it down into smaller networks as well. Right, so let's think then, how many IP classes are there, or kind of were there, since again this is not really used, and what are some problems with them? So right, hopefully you remember 3 classes are A, B, and C. The main problem is that the network ID, host ID is at a fixed position, or fixed bit position. Right, hence people won't use all of the host IDs that they're kind of allocated or that they bought. Right, therefore that's going to be low IP address utilization. And since we only have 4.3 billion IPv4 addresses, then we don't really want to waste them. Right, let's think, how does CIDR solve this, and right, what is the notation like? So right, the network host ID can be split at any bit position, right, hence networks can be allocated only the number of host IDs they need. For example, this, /24, right, means 24 bits used for the network ID, right, while the remaining 8 bits would be for the, host ID, right, device ID. Right, so let's explain what the IP address, right, 11.22.33.44 and subnet mask, 255.255, right, 00, right, mean in terms of the network ID and device ID. Right, so this means, the first 16 bits, and, that's because here, right, 255.255, right, 16 ones. Right, the first 16 bits are going to represent the network ID, the last 16 bits, therefore, those zeros, right, they're going to represent the host ID. Right, hence the network is 11.22, and the valid range of device IDs would be 11.22, right, 00, to 11.22, right, 255.255. Again, I mean, okay. So if you want to be super technical, I guess we say 0 is probably going to be reserved. Likewise, this very end address, that's also probably reserved. But But yeah, well, all right, okay. So to be honest, actually, they would never really ask this in A level. They might ask, I guess. Yeah, okay. Right. Well, okay. So when I say they wouldn't ask the range, I mean, I guess maybe they could. Like, I can't remember seeing it. But what they might ask is they might say, well, if we have, for example, this subnet mask, then how would we work out, how many different devices we can have? And well, of course, here that's going to be, 2 to the power of 16. So yeah, right, okay, all right, yeah, okay. So I would say, well, don't worry about this -2. Yeah, just sort of, do the basic one. All right, then finally, so just list some advantages, disadvantages of breaking the network down into smaller subnets. Okay, so some of the advantages, well, one, greater utilization of IP space. Well, yeah, right, okay, all right. So again, this is the same as CIDR, since we can kind of specify exactly how many bits for the network or how many bits for the host. Yeah, unlike IP classes where we can't. Right, it's also going to be easier to organize and maintain, right, since less devices are on each network. So basically, it's easier to manage, lots of small networks, right, rather than one massive network with like thousands of devices. Right, also improve security, right, e.g., I guess, specific firewalls for different networks or, different subnets, right, different access rights, different permissions. Right, also network separation. Now, I guess, one, that can be privacy. I think in a minute we'll also see about, all right, so if, let's say, one network gets, sort of some malware, well, it's going to be harder for that malware to spread right onto, the other subnets. Yeah, so I think this one, right, well, threat containment. Right, so it's going to be harder for hackers or malware to traverse network, and that's something you often see in cybersecurity. Okay. So cybersecurity, they often mention network traversal. So what that means is if one computer gets infected, right, how can the hackers go from that one computer, to like all of the other computers in the network? Yeah, that's obviously going to be, I guess, one of their goals, right? If they're a hacker. Right, so it's also going to improve efficiency because you're not going to have one router with hundreds or thousands of devices all sending packets to it. Yeah, and I guess if you had that, well, then you have right, okay, all right. So then you're going to have a problem where all right. So let's say the buffer is going to get full, right? You're then going to get dropped packets, right? The router's not going to be able to handle it, right? It's going to have to be resent. Right, I guess a sort of slight disadvantage where it's probably going to require a network administrator to set up. Yeah, or even if you did try and do it yourself, I mean, you'd probably have to, research online how to actually set this up. And to be honest, like, that's for people here watching this video. Now, most people doing AS are sort of, I guess, fairly competent with computers. If you're talking about, just sort of like regular people, then I guess probably setting up a subnet is going to be sort of, beyond their understanding, to be honest. So okay, all right, okay, so that's why if you wanted to do this, well, then you'd need a professional, right, an actual, network administrator. Right, again, okay, all right, so again, I'll put this in orange since I wouldn't really say it's a big disadvantage. It's going to be more expensive due to the requirement of having, I guess, extra routers, right? Well, okay, all right, okay, so due to the requirement of having a router for each subnet. Now, again, if you're like a business, a hospital, a school, then paying for sort of like 10 routers is kind of a trivial cost in comparison. Okay, all right, okay, so in comparison to sort of the salaries you're having to pay, right, in comparison to all of the equipment you're having to buy, things like this. All right, anyway, guys, I think okay, all right, so I think that was the last point. Now, as always, hopefully this video is useful. If you've got any questions, ask in the comments, and I'll see you again in the next video.